Hello, welcome back. This is Jeffrey, and the topic we're going to be discussing today is composition of functions. So here's the learning objectives. In this section, you'll learn to combine functions using algebraic operations, create a new function by composition of functions, find the domain of a composite function, decompose a composite function into its component functions. So let's get started off with combining functions using algebraic operations. So first of all, let's suppose we need to add two columns of numbers that represent a husband's and wife's separate annual incomes over a period of years, with the result being their total household income. We want to do this for every single year, adding only that year's income and then collecting all the data in new column. If W of Y is the wife's income and H of Y is the husband's income in year Y, and we want T to represent the total income, then we can define a new function. T of y is equal to H of y plus W of y. And here are some other algebraic operations that you will have to remember for combining functions. So first of all, we got addition, subtraction, and then multiplication, and finally division. Just keep these in mind that you will have to know like these for doing problems like about combining functions. The second one is creating a function by composition of functions. So the process of combining functions so that the output of one function becomes the input of another is known as composition of functions. The resulting function is known as a composite function, and we represent this combination by the following notation: f composed with g at x and f of g of x. They are the same thing, so you just have to note that they're the same thing. Yeah, for example, if f of x is equal to x squared and g of x is equal to x plus 2, then f of g of x is going to be equal to f of x plus 2, which turns out to be x squared plus 4x plus 4. And same thing with g of f of x is going to be equal to g of x squared, which is just x squared plus 2. The third thing, finding the domain of composite function. So as we discussed previously, the domain of composite function is such as f of g is dependent on the domain of g and the domain of f. Let's assume we know the domains for functions f and g separately. If we write the composite function for an input x as f of g of x, we can see right away that x must be a member of the domain of g in order for the expression to be meaningful, because otherwise we can't complete the inner function evaluation. However, we also see that g of x must be a member of domain of f. Otherwise, the second function evaluation if in f of g of x cannot be completed, and the expression is still undefined. Thus, the domain of f of g consists of only those inputs in the domain of g that produce the outputs from g belonging to the domain of f. Note that the domain of f composed with g is the set of x such that x is in the domain of g and g of x is in the domain of f. Here is just a short definition of the domain of a composite function. A domain of composite function f of g of x is the set of those input x in the domain of g for which g of x is in the domain of f. Alright, the last one is decomposing a composite function into its component functions. So we can write function as a composition of two simpler functions as well. There may be more than one way to decompose a composite function, so we can choose the decomposition that appears to be the most expedient. We'll come back to this later, just not right now. Yeah. So let's do some practice questions. The first one, using the functions provided, finding f of g of x and g of f of x. So let's say f of x is equal to 2x plus 1 and g of x is equal to 3 minus x. I'll give you guys 30 seconds to work on this, starting from now. Alright, so here's the solution. That's being by substituting g of x into f of x. So f of g of x is going to be equal to 2 times the whole thing, 3 minus x plus 1. So it's equal to 6 minus 2x plus 1, which is also just 7 minus 2x. Now we can substitute f of x into g of x. So g of f of x is going to be equal to 3 minus whole thing 2x plus 1. So it's going to be 3 minus 2x minus 1, which gives us negative 2x plus 2. And that's your solution. Second question, suppose you have two simple functions. The first one is f of x is equal to 2x, and the second one is g of x is equal to 3x plus 1. And we want to find h of x, which is g of x minus f of x. Then, yeah, find h of x. I'll give you guys 30 seconds to work on this, starting from now. Alright, so here's the answer. H of x is going to be equal to g of x, which is 3x plus 1, minus f of x, which is just 2x. So that's going to give us x minus 1. And that's it for today's lesson. Thank you for listening.